So in this video we're going to look at completing the square. So the method allows us to identify the coordinates of the turning point or stationary point of the graph of a quadratic. This is particularly useful if the graph has no roots, so it doesn't cross the x-axis. So given a quadratic function in the format y equals ax squared plus bx plus c, to sketch the graph of the function, a parabola, we express the equation in the form y equals a upon x plus p all squared plus q. In other words, we complete the square. In this form, the stationary point is negative pq, and if the x squared term is positive, we have a minimum stationary point, and if the x squared term is negative, we have a maximum stationary point. So in this example, we want to express 2x squared minus 8x plus 9 in the form a upon x plus p all squared plus q, and hence state the nature and the coordinates of the stationary point. So the first thing we want to do is complete the square. So we're going to take our 2x squared minus 8x plus 9, and the first thing we're going to do is we're going to factorize the first two terms only. We're going to leave the plus 9 separately. Now we want a, which is a numerical value, so we're only taking out a numerical common factor, and so that would be 2 upon x squared minus 4x, and then we've got our plus 9. Now the next thing we want to do is we want to complete the square of the x squared minus 4x bracket, remembering that we'll have a constant term that we need to take away. So to complete the square, we have the coefficient of our x term, so we're going to end up with 2 upon x minus 2 all squared, and then take away the negative 2 squared, which is take away 4, and then remember we need to add the 9, and we're keeping that completed square part in a separate bracket, because the next thing we have to do to combine that negative 4 with the 9, we need to multiply it by the coefficient of our x squared term. So we're going to end up with 2 upon x minus 2 all squared minus 8 plus 9, and that's going to give us 2 upon x minus 2 all squared plus 1. So the question asks us to state the nature of our stationary point, and you can see we've got a positive 2x squared, so we're going to have a stationary point that is a minimum stationary point. And then the final part of the question asks us to work out the coordinates of the stationary point, and we're going to use our completed square format, and we know that the coordinates of the stationary point are going to be negative pq, and so our minimum stationary point is going to be 2, 1. Now one thing to note is that we need to make sure that the equation of the quadratic is in the form at y equals ax squared plus bx plus c before we attempt to complete the square. So in our next example, we want to express 7 minus 6x minus x squared in the format q minus x plus p all squared. The first thing we want to do is write it in the format y equals ax squared plus bx plus c. And that means we need to switch the negative x squared and the 7 around. So we end up with y equals negative x squared minus 6x plus 7. So now we're going to take out the common numerical factor of the first two terms. So that's our minus x squared minus 6x. And so our common factor is going to be negative 1. And that means we've got x squared plus 6x inside of our bracket. And then we're going to leave the plus 7. So now we need to complete the square of the x squared plus 6x. And again, we have the coefficient of our x term, so we're going to get an x plus 3 all squared bracket. Now remember, that's going to give us a plus 9 that we're going to need to take away. And remember, we need to keep this part inside a separate bracket because we need to multiply by that negative 1 in order to combine the negative 9 with the plus 7. And so we're going to end up with negative x plus 3 all squared plus 9 plus 7. Now we're going to need to collect our like terms together, but if we go back to the original question, it's asking us to put our answer in the format q minus x plus p all squared. And so we're going to put our 9 plus 7 at the start, so that's 16, and then we're taking away the x plus 3 all squared. Now, the question then says, hence state the nature and the coordinates of the stationary point. So our nature, this time we've got a negative x squared. So that means that we're going to end up with a maximum turning point or maximum stationary point. And then we're going to use our completed square to work out what our coordinates are. So the x coordinate, we equate the x plus 3 bracket to 0. And so our coordinate is going to be negative p. And our y coordinate is going to be the constant q. And that means that our actual coordinate of our maximum stationary point is going to be negative 3, 16.